Okay, today's lesson, day 10, is still solving these polynomial equations, but today we're going to add in imaginary roots. So we're going to be getting some i's back in the play here. The process is the same, but our answers, some of them will have i's in them. So for example, in number 1, this has 4 terms again, so we're going to want to do factor by grouping. The GCF of the first group is x squared, leaving x minus 5. The GCF of the second group is 5, also leaving x minus 5. When we get our factors, remember the GCFs pull out to one factor, x squared plus 5. The other factors that were repeated show up as the second factor, x minus 5 equals 0. When we set each one of these equal to 0, the right side is really easy. The right side's just going to be x equals 5. On the left side, though, we have x squared plus 5 equals 0. If we have that, we can bring the 5 over and make it x squared equals negative 5. When we take the square root of that, though, we're going to get x equals plus or minus the square root of negative 5. And remember, when you have a negative inside, it pulls out as I radical 5. So we do have 3 solutions to this problem. The first solution is a real solution, x equals 5, that came from here. The second 2 solutions are imaginaries, x equals I radical 5 and x equals negative I radical 5. And notice we had 2 roots that were imaginary. That's going to be important. The second equation, we're going to have to get set equal to 0. X to the 4th plus 3x squared minus 4 equals 0. This one has an x to the 4th in it, but it's only a trinomial, so we can try to factor this. We have an x to the 2nd times x to the 2nd. This tells me the signs are different, so I need a plus and a minus. And factors of 4 that would give me a 3 are 4 and 1. Now, each one of these still results in an x squared, so we're going to have to do some more work to them. This side is going to be x squared plus 4 equals 0. Let's do the square root method to get x squared equals negative 4. When you take the square root of each one of those sides, you're going to get x equals plus or minus 2i. The square root of 4 is 2, but because of the negative, it's going to be 2i. So plus or minus 2i. On this side, we'd have x squared equals 1. We could do the square root method again. And if we do the square root method to those, the square root of 1 is just 1. So we'd get plus or minus 1. So again, we get 4 roots. X equals plus 2i, x equals negative 2i, x equals 1, and x equals negative 1. Each of those shows up once, so you have a multiplicity of 1 for each one of those. And again, it's important to note, when I did my equation, 2 of the roots were imaginary. The others were not. In example 3, it's a GCF problem. You can pull an x out of there. So x parentheses x squared plus 10x plus 50 equals 0. This side is easy. X equals 0. There's a 1 answer with a multiplicity of 1. On the other side, I'm going to get x squared plus 10x plus 50. If I try to factor that, I'm going to be lost. I don't have any numbers that multiply to 50 and add up to 10. So I have a couple of choices. I could do the quadratic formula, or I could do completing the square. Since 10 is an even number, I chose to complete the square. So I have x squared plus 10x, and I sent the 50 to the other side for negative 50. Then I took half of the 10 and squared it, so I have a plus 25 and a plus 25. Don't forget to do it to both sides. Over here, when I write it as a squared, it's x plus 5 squared. And over here, it's negative 25 on the right. Take the square root of both sides. The square and the square root undo each other on this side. They're inverses. So x plus 5 equals, and the square root of negative 25 is plus or minus 5i. So sending that 5 over from the x, it's going to be x equals, this goes over as negative 5, plus or minus 5i. So we got 3 roots to this question. We got x equals 0, x equals negative 5 plus 5i, and x equals negative 5 minus 5i. So 3 solutions, which we knew we should get because it was x to the third, and the multiplicities are all 1. In example 4, you have 4 terms. So to me, that suggests that you should be looking to factor by grouping. So here and here are our 2 divisions. The first one has a GCF of x cubed. That leaves me x minus 3. The second one starts with a plus. We haven't seen that very much. So we're just going to pull out a 4 there, positive 4, and that also leaves us x minus 3, and it's equal to 0. Again, the ones that were the GCF make the first factor, x squared plus 4, and then the ones that were the repeats are the second factor, x minus 3 equals 0. We still need to also think about, oh, I made a mistake. Let's start that one over. On this one, when we took out the x cubed, that left us x minus 3 plus 4x times x minus 3 equals 0. Sorry about that. When I took out the GCF pieces, I have x cubed plus 4x as 1, and then the repeated one was x minus 3 equals 0. When I look at the 2 factors, this side's easy. X minus 3 equals 0, so x equals 3. So one of my roots is positive 3. When I look at this first one right here, I still have a GCF in there I could take out. I could take out an x, which would leave me x squared plus 4. This x would also turn to 0. That's easy. What's left now is x squared plus 4. X squared plus 4 would have to equal 0. So x squared could equal negative 4. When I take the square root of that, the square root of negative 4 is plus or minus 2i. So this was a 4th degree equation. I have x equals 0, x equals 3, x equals 2i, and x equals negative 2i. And again, please take note, how many imaginaries did you get? 2. The rest of the examples you should try on your own. The first one should be a factor by grouping. Number 6 should be a regular factoring question. Number 7 should be a GCF, followed by, I did a perfect squares, or sorry, square root method. Complete the square method. Sorry, 3rd time's the charm. And on the 4th, example 8, because there are 4 terms, again, I think you should try to do factor by grouping. You should try these questions and check your answers on Schoology. Now, at this point, all of the lessons have been recorded and taught. You are ready now to think about doing the review after your last homework assignment is finished.